Yeah, so there is no response. So are your mics working? Prabhakar, Jaishuriya, Suraj?
Hello, yes, sir.
Yes, sir.
Okay, yeah. So can you please wait for 5 more minutes?
Yes, sir.
Then we'll start, okay?
Oh.
All righty. So let me share my screen. I think it is visible, right? Anyone?
Yes, sir.
Okay, yeah. So before we start, let me ask you, like, do you have any queries regarding the previous assignment or regarding anything of the previous lecture? Like, what are the different deformation mechanisms and all those things? Do you have any query regarding those? Okay, I guess the answer is no. So
Sir, I have one.
yeah, please.
Sir, in this location, like sir, I asked about temperature and pressure conditions. So sir, आपने बताया था कि डिसलोकेशन लाइट अगर टेम्परेचर इनफ नहीं होगा तो रिवर्स डायरेक्शन में कंटिन्यू उसका फ्लो होगा, तो वो सर कैसे होगा, वो सर नहीं समझ आया।
The reverse direction में continue होगा. Where is it written? Can you guide
मैंने
me?
डाउट पूछा था तो सर आपने रिप्लाई दिया, उसमें ये लिखा हुआ है।
Uh,
At a higher temperature, when a dislocation light gets affected by an obstacle, it converts to the dislocation climb.
yeah, so it will change into dislocation climb. So the mechanism, if the crystal is still trying to deform and accommodate deformation, like accommodate strain within itself, so what will happen? So the next phase of the different kind of deformation mechanism will happen. So that is called dislocation climb.
Yes, sir. पर उसके साथ आपने लिखा कि if it doesn't have sufficient energy, then the
Uh-huh.
dislocation glide continues its process in reverse direction.
I think, let me check. Okay, so I don't think that sentence is correct. So actually, in this week we had a very tough schedule, so we cannot answer the questions in proper time and all that those things. So that last part is not correct. Like in dislocation uh, glide, there is no particular direction. I mean, like the dislocation happening this way or that way. It's not like that. So what is happening? You have a grain, and within that grain, when you dislocation glide is happening, so what will happen? The orientation of that crystal points or that particular motifs, so that will vary, right? So like this is one motif point, and this is the orientation. Say for example, this is C, and this is A and B. For an hypothetical crystal, just assume that. So so initially it was like parallel, so the c-axis of all the motifs were like this, right? But when you incorporate deformation due to so any crystal has some amount of defect within it. So when you deform the crystal, what will happen due to the interaction with the defects? So this lattice will change orientation, right? So that is called misorientation, right? So the difference in orientation of two adjacent motifs or lattice points we call misorientation. So when you increase the deformation, when you continue deforming the crystal, what will happen? That this misorientation will increase, right? So by when it will increase, so that increment of misorientation that will propagate, right, like an wave, not literally like an wave, but it will propagate. This misorientation will propagate. So
Yes, sir.
that is called dislocation glide. So there is no direction whatsoever, right? So I mean, particular direction, and it's not like that.
yes, sir. सर तो अगर सफिशिएंट टेम्परेचर नहीं होगा तो उस केस में सर क्या होगा फिर?
See, there is see what is happening at a particular temperature and pressure. What is happening? So we see like everything around us is static, very solid, very stable. But that is not the case, right? So everything is vibrating at its mean position, right? But our eyes or senses is not enough to see those vibrations. So even when you go inside the earth, what is as the temperature increases, so the vibration increases, right? Because of the temperature. So anything that is vibrating around the mean position, the amplitude will increase, right? So what is meant by that sufficient energy? So that vibration is important for the dislocation glide to propagate, right? For suppose if you have an obstacle, say for example any kind of another foreign element sitting at a particular place, and you want to cross that particular element. So what you have to do is you have to continue like this will you continue the deformation at another level, right? So another upper tier, say for example, so that jump is called climb, right? So if there is not sufficient temperature, so that dislocation will be arrested, right? So there won't be any dislocation climb, right? And so there will be dislocation entanglement, and like knots, like if you have a it's like the headphones wear, right? If you put it in the box or any in your bag or something, so it gets tangled, right? So the dislocation lines will entangle and the grains will harden, right? If there is sufficient temperature, and then when it gets hardened, what will happen? It may produce ductile failure or brittle failure, like those things, right? But if and new grains will so recrystallization will happen at a at a premature recrystallization will happen, so new grain boundaries will form, so these things will happen, right? But if so if it gains it's can produce can accommodate deformation, so then the subgrains will form, the grain size will the dynamic recrystallization will be attained at a later stage, and with sufficient temperature the grain boundaries will be straighter, much more straighter. So yeah, these things will happen.
सर एक सेंटेंस उसमें लिखा है, बस सर आप इसको वेरीफाई कर दीजिए कि ये सही सेंटेंस है कि नहीं। उसमें लिखा
अच्छा।
हुआ है कि अगर टेम्परेचर जो है वो सफिशिएंट नहीं होगा
हम्म।
तो ग्लाइड, ये सर ये इसमें नहीं, वो पीडीएफ में सर लिखा हुआ मेन पीपीटी में, इसीलिए ये डाउट हो जाता। उसमें लिखा था कि टेम्परेचर अगर सफिशिएंट नहीं है तो ग्लाइड कंटिन्यूज टू ट्रैवल। सर मुझे ये डाउट है कि ग्लाइड कैसे कंटिन्यू करेगा? अगर ऑब्स्टेकल रहेगा तो वो वहीं पे जाके रुक जाएगा, टर्मिनेट कर जाना चाहिए उसको। तो
No, the thing is that glide is see suppose this is your no, not this one. Suppose okay, suppose okay, I'll use the note thing. Okay. Okay, so suppose on the way there is an obstacle like this, okay, and it was traveling in this way, but here you were seeing only one dimensional. So this image is basically, so if you want to make a like a 2D image, it's also there, right? It's also there, and it's also in the third dimension also, that is pointing upward from the screen and inside this and inside the screen, right? So but this element or this atom this I mean this obstacle has its own boundary, right? So what will happen if I see from the plan view? Suppose this is the plan view, here is an obstacle sitting and it got arrested here, so it can go in this direction, right? So the process, so the glide and climb, these are two different processes. So the shift of one process to another process requires the temperature. If the temperature is not there, so the same process that the glide will only happen. So after certain point of time there is multiple dislocation lines, so at that those will get entangled and the recrystallization will happen. But if it allows climb, that recrystallization will happen at a later stage. Are we clear?
यस सर।
Okay, yeah. Okay, yes. Anything else?
यस सर।
Yeah.
सर वहाँ से सर पीडीएफ जो है पीपीटी के वो डाउनलोड नहीं हो रहे हैं। वहाँ पे एरर दिखा रहा है, मैंने सर ईमेल पे आपको लिखा था।
Okay, so don't send me personal emails. So any doubt that you have, please send it in the discussion forum. Okay. So from there, we will, we will be able to see. So other people also who can see those things and they can act on them, right?
Yes, sir.
So those, I think I will have to talk to this. Like we don't have access to those PDFs, but that is opening fine with our systems, right? Actually, I will have to check again. If that is not happening, then we may have
Yes,
to
sir.
ask.
फर्स्ट कुछ लेक्चर्स जो थे वो सब अच्छे से हो रहे थे स्टार्ट में, और उस समय डाउनलोड भी हो रहा था। अभी सर कुछ दिन पहले प्रॉब्लम है सर, अभी डाउनलोड नहीं हो रहे हैं।
Okay, all right. So you say send that thing on the ask a
तो
question
मैं फिर
forum.
से उसमें फॉर्म में डाल दूंगा।
Yeah. So there will be people, and we'll just forward them to just look into this, and they will fix the issue. I think. Okay. Okay. So anything else?
टॉपिक से रिलेटेड आप सर पढ़ाएंगे तो उस टाइम पूछ लेंगे, जो इसी जो आप आज बताने वाले हैं।
Okay. So Jashurya and Prabhakar, do you have any doubt?
No, sir.
Okay, Prabhakar. Okay, he's unresponsive, so I'm moving on. Yeah. So today's lecture will be about the deformation, different deformation structures. So, for example, foliation, lineation, all those things. So you can see the PPT, or should I, make it full screen? Can you see it?
यस सर।
Okay. Okay. Yes. So when you deform a rock, what happens after a certain point of time? You develop some kind of fabric. So what is a fabric? So fabric is basically, some kind of pattern that repeats itself, right? So if there is no repetition of pattern, if there is no repetition of, say for example, any kind of say the crystals are entirely random. So if you have suppose you have a sandstone, you're looking at a sandstone, that in that you have a random orientation of grains and all, so there is, we call them that there is no fabric, right? But after certain point of time, so when you deform the rock, what happens, you tend to develop the fabric. So some kind of hiatus, some kind of discontinuity that develops in the rock. All right. So we can differentiate them or categorize them into two divisions. So the one is the one dimensional fabric, so that is the linear fabric, and the other one is the two dimensional fabric, so that is the planar fabric. So that we call them by different names. So we can call them as foliation, we can call them cleavage, we can call them cystosity. So let's not go into those terms. So the division of these terms are like used by different authors in a very different way, but different ways. But that the sharp boundary of those things are not really categorized. I mean, that is not fixed. So yeah, so that is that. But usually the structural geologists, they prefer to use the term foliation and cystosity. But for example, if the cystosity is very spaced, and sometimes we use them cleavage, right? So but in general everything is foliation. All right. Yeah. Okay, yeah. So there are. Why do we study these fabrics? because of, as it is already mentioned in the lecture. So this I will be covering mostly. I will try to cover two week lecture today, but I'm not sure if I can. But these two sections are very descriptive, so I don't need to explain these things very much, because that is very well documented in the online lectures. So yeah, so why do we study this fabric? Because whatever we see in a rock, that say for example any kind of deformation signatures in terms of fabric, those are the clues of what the rock actually experienced, right? So suppose we are seeing a particular, because there is no other way that you can tell, okay, so these things happened and that thing happened, so those things are not there. So what we try to observe those different kinds of fabrics, say for example plan fabric or linear fabric, and we try to establish a geometric relationship between them. So maybe the force is acting from a particular direction for a particular time, or maybe there is some hierarchy of forces. So each force set is basically correlated with one deformation event. So by this approach, we actually try to figure out like what happened with the rocks. All right. So this is why we study both the linear and planar fabrics. So but if we any kind of hiatus, any kind of fabric that can not necessarily they are always the result of deformation, right? So those who are responsible for the deformation, those are called secondary fabrics. The primary fabrics are those fabrics which produced when the rock was actually formed. So are you familiar with the Wilson cycle? Are you familiar with that? Do
No,
I have?
sir.
Okay, so in Wilson cycles, that's a rock cycle. So what happens in a rock cycle, that igneous rock can transform into a metamorphic rock, and then a sedimentary rock can transform into the igneous rock. So those things, are we familiar now? Rock cycle?
Yes, sir.
Yeah. So in the particular so in this, the insult cycle has three vertices. So in each vertices you have like igneous rock, metamorphic rock, that is the diagenetic rock here, and the sedimentary rock. All right. So these points maybe you can get like different kinds of planar fabric, but those are not due to deformation, right? So say for example here we are seeing the primary, some igneous layering, so the alternative dark and light color band, so those are not due to deformation. Maybe that can happen, say for example when the igneous rock is settling or crystallizing, so different kinds of melt is enriched the chamber, right? So the magma chamber, so different kinds of melt, so due to this differential composition you are getting this layered structure. So usually what happens that if you have a fluid, or say for example, in sedimentary rocks, so what happens, so everything crystallizes, or this settles in a fluid environment, right? So they tend to follow the gravity, so they tend to follow the horizontal plane, right? So at that time maybe those planes were horizontal, right? Yeah. So and that thing is also okay. So this image is not clear. It was clear in the lecture video. Yeah. So that is also, so these fabrics are very penetrative structures. What do we mean by penetrative structures? That it is also present in the mesoscale, that is a hand specimen scale, and also it is present in the microscopic scale. All right. Yeah, so these are diagenetic foliations that happen in the process of diagenetic. This is some bedding foliations, as I already said, like they tend to follow the horizontal line. Yeah. So yeah, see, there is a difference between these image and these image, right? So these fabric,
हेलो
yeah,
सर, पेंटेटिव मीन्स हम ये कह सकते हैं कि नंबर में सर ज़्यादा रहेगा, या फिर पेंटेटिव मीन्स साइज में ज्यादा रहेगा कि अंदर तक रहे, मतलब कैसे मैं बताऊँ समझा।
penetrative,
अच्छा
right?
पेनिट्रेटिव मतलब पूरे वॉल्यूम में रहे ना। तो
Penetrative.
सर पूरे वॉल्यूम में रहने के लिए दो तरीके हैं, या तो सर वो नंबर में ज्यादा हो या तो साइज में ज्यादा हो, तो सर कौन से वाला बात सही है।
Okay, so let me have to draw a picture. Yeah, see, suppose you are seeing, so this is what this is, say for example 10 centimeter. Okay, so this scale, so you are seeing a hand specimen, right? And you are seeing the plagioclase lats are oriented at a particular direction, right? So in the hand specimen, say for example, you are seeing this, all right? This is a gabbro, say for example. Okay, so this is a gabbro. So when you see these in a field scale, what you will see this beautiful. So in a field scale, you are seeing. So this is 1 meter, right? So you will see like this is white bands and this is dark bands again. So yeah, so you will see these white bands, and then again you will see these white bands. You will see these white bands. So there is some kind of fabric you will notice. Okay, so now you made thin section out of this hand specimen, and now you were looking at a much finer scale. So for example, this is 200 micron. Okay, so in that also you will see one plagioclase grains oriented like this. Okay, so this fabric, this repetitive pattern, it is in the field scale, it is in the hand specimen scale, and it is also in the microscopic scale, right? So that is what I meant when I say penetrative structure. So it is not that it is only present in the field scale, but when you see in the microscopic scale, or if you see the rock under the microscope, so that fabric is absent, so everything is homogeneous. It is not that. All right, it's not about the number.
यस सर।
Okay, yeah. Okay, yeah, so there are some different images of how any kind of planar fabric can occur. What are the different mode of occurrence of the planar fabrics? So this is an introduction to what is a secondary foliation. So these alternating dark and light color bands, these are the bedding planes. So these are the beds, right? But if you follow, if you look closely, you can see these kind of lines. That is, if you follow the cursor, so these lines are basically another set of foliation. So that is a cystosity, right? So that is produced due to deformation. So we will know how, but this is a beautiful example. Like the primary and secondary fabric, they can coexist, and the structure, the job of a structural geologist is to differentiate these two, and then reach into different conclusions, right? Yeah. So I don't think I have anything else to describe in this slide. This is one migmatite. You can see like the foliations are developing in this rock. So yeah, so I think I'll move on to the next slide. If you do not have any question, then I'll move on to the lecture 18. Is it all right?
यस सर।
Okay, yeah. Yeah. So yeah, as I said, like there are different kinds of foliations. So it is written here, explicitly defined, like what is spacing, what is the spatial relationships, and all those things. So secondary foliation can be spaced or continuous. What is meant by spaced? That it can be suppose it's like a dotted line or maybe a dashed line, right? So maybe in school or in colleges, we always we always have seen those dotted lines to note something. So in rock also, these foliations might not be continuous. It might be like it's here, and then if you follow that trend, the particular foliation is absent, but again after some distance you will see that again the foliation. So it will be occurring repetitively, but not in a continuous fashion. So there is no continuous connection, like, but the orientation will be same. So that will belong to the same foliation family, but they will be that is not continuous, right? So spaced secondary foliation can be of compositional, can be disjunctive, or can be crenulation. So what is meant by disjunctive, then that is not really what should I say, not continuous, but that is not say follow a same train, so that will be little bit of uh, carvy or something like that, right? But the difference between disjunctive, yeah.
Sir, what is anastomosing?
Anastomosing is like okay, so we know the river channels, right? So in river, so this is the straight channel, right? And this is the meandering channel, right? And this is anastomosing channel, right? So these are the islands, right? So these are the islands. So what is happening here? So water is, so these channels are like that. So water is flowing like in this way, right? So these are anastomosis. This pattern is called anastomosis. Something like it branches out and then again gets connected, and then again after some point it branches out and again gets connected. Maybe it another thing branches out from here and connected here, maybe, and again branches out here. So this pattern is called anastomosing. So it branches out and then gets connected, branches out, and so it creates a particular type of pattern, right?
Yes, sir.
Okay, yeah. Um, okay. So, but the difference between disjunctive and crenulation is that, so crenulation is little more periodic, right? So the stylolite, if you see the stylolite, so the even you will see the the photos, the pictures, photographs of stylolite later in this lecture, but those are not periodic, right? So crenulation is little bit more periodic. So in case of continuous cleavage, you can have fine or coarse. That is a very coarse distinction. But yeah, people distinguish due to the sake of describing the whole thing. So we tend to create those terms so that we do not face ambiguity. Suppose you are describing one outcrop, and you have to write those down, and those words are the only picture of those outcrop, right? Those are the descriptions. So those words that you've written in your notebook or in your report or whatever you are writing, so those things are the description of those rocks. So what are those rocks? If someone asks, they will have to go through your notes. That's why these terminologies are important, like which kind of granulation, which kind of cleavage we will call what, and all those things. Okay, yeah. So yeah, we can use this scale, but this is not so all of this this scale is not really, you know um, you can have your own scale, but if you are using this scale, it's you have to refer, like, you can draw this scale somewhere, you can keep this scale with you if you want to give those description. And from that, say for example, you have to measure those spacings, and then you will say, okay, so this is weak spacing, this is moderate spacing, this is strong spacing, like that. So these are all the, what should I say, gears of field geology. Yeah, so this is one. So you are asking about the anastomosing cleavage, right? So this is one disjunctive anastomosing cleavage. Can you see the pattern?
Yes, sir.
Yeah. Yeah, so these are called, so the space between them are called microlithons, as it is written here. These things are pretty easy to go through, I think. Yeah. So in a field scale, you're seeing this disjunctive cleavage. You have microlithons in between. So microlithons, the rock is more or less homogeneous. Yeah, in micro scale also you can see the disjunctive cleavages. Okay, so these are cannulation cleavage. Yeah, and I was talking about the periodicity. You can see from here, right? So this is very periodic, right? So each the wavelength of this cannulation is more or less equal throughout the region. All right. Yeah, so this is also a microphotograph. You can see the cannulation here. So the waves, the is present even in the micro scale, right? So you are seeing it in the say for example in the mesoscale and the field scale, and you are again seeing in the micro scale. So that is what I meant when I said that these kind of fabrics are penetrative. So it is present even up to the grain scale, right? Okay, yeah, so this is one table. You can go through this and you will get some idea like what are the different kinds of foliations happening in different kinds of rocks. And so this is transposed layering. Okay, so this is very
सर इसमें थोड़ा सा सर मुझे पूछना है।
yeah.
सर इसमें ट्रांसपोज्ड जो लेयरिंग है उसको सर हम लोग इंटरसेक्शन लिनिएशन पे नहीं इसमें कंसीडर करते हैं।
Okay, so the thing is your bedding is so, um so for example uh, the intersection will happen at with the cleavage and the bedding, or like whichever deformed rock you have there, right? So this plane, this horizontal plane is not a cleavage plane, right? So the intersection lineation means the intersection of what? It has to be the intersection of cleavage and the bedding plane. So the cleavage planes are vertical here. So whatever we see on that vertical plane, those are called intersection lineations, right?
यस सर।
Okay. Yeah, so these are some transposed foliations. Okay. So yeah, we are going into folds. Yeah. Okay, yeah. So what happens in the rock is not really a homogeneous material, right? So in the rock, you can have anisotropy, you can have material that extending, like following the strike, but the material, but that will be a new rock maybe. So it might be sandwiched between different kinds of rocks, right? So the sandwich layer, so we'll have a different competency. By competency I mean that the hardness or the viscosity, you may say viscosity, or say for example Young's modulus, the material will be softer, right? More um, incompetent, right? So the competent layer will be the harder, with higher viscosity, with higher Young's modulus, like those things. Okay. So when you have that, what is happening now? You try to deform this thing. What will happen? The
सर
we, yeah,
तो सर कॉम्पिटेंट एंड ब्रिटल सर सेम होते हैं या सर उसको अलग अलग बोलेंगे?
no. Competent and incompetent layer, those are say a layer that is competent can be incompetent with so it always how should I put it? So if you have a collection, say for example this yellow rock and this pink rock, right? So in this structure, in this amalgamation or in this collection, this rock is competent, right? This is incompetent, right? So it will bend, it will
सो
buckle.
मतलब जो रॉक्स को बेंड करना डिफिकल्ट होता है उसको हम कॉम्पिटेंट रॉक बोलते हैं.
Yeah. So the thing
ओके
is,
सर.
it has to flow, right? It has to flow through this incompetent layer, right? So it has to flow through this. So it will make weight for this rock because it has a higher competency, right? So it will buckle, right?
यस सर.
Okay. Okay. So what happens that it has been seen that when suppose you have a material and the rock is deforming under the pressure and temperature, so it will produce some kind of foliation, right? Some kind of foliation, that is, because there is no folding initially, just some foliations, and then you fold them more, you deform them more, right? So what will happen, the competent layer will fold, and the foliation that was previously created, so those foliations will change their angles, right? So it will be something like this. Okay, so previously it was like this, so now it has a different say for example different layer, so the angle at which the foliation will form, it will be different. So those mimic the physical process of refraction, so we call them cleavage refraction, right? So it has nothing to do with the optical refraction and all those things, but the change in angle is there. So the foliation will come in this direction and then suddenly it will change its course for a different rock, and then and again it will follow the previous trend, right? And for a fold, as I was saying earlier, for a fold, this refraction does a very interesting phenomena, right? So when you have uh, okay, so maybe I'll go through the next slide. Yeah, so when you have for a competent layer, which is this one, which is this yellow one, so this will converge, right? So this will converge towards the fold's closure, right? So the inner part of the fold, so it is this one. For this fold, the inner part is this one, in which this to this fold, the inner part is this one, right? This one. So all these lines, these cleavages will converge towards the fold's core. But for the incompetent layer, it will diverge from the fold's core, right? So if you follow this white line, so this is also a fold, we can say, right? So this will diverge from the fold score towards the fold score, and again it will converge to. So it happens like that, or like that, right? So from that you can actually in the field see, in the field you do not have, so how, why do how do we say readily like this layer is more competent than the other? So one way is to study or is to observe the cleavage refraction. Okay. Yeah, so here is some natural examples. Okay.
हेलो
Okay, yeah.
सर. आई डिड नॉट अंडरस्टैंड क्लीवेज ट्रांजैक्शन clearly in the lecture video. Yes sir, this one.
Okay. See, um, the foliation, what does happen with the foliation when you have, say for example, suppose you in the field you are seeing this beautiful fold, all right. But if the foliation, it is not necessarily true that the foliation will be always, parallel to the axial plane of the, do you know what is the axial plane of the fold?
Yes, sir.
Okay, so suppose yeah, so this is a fold, so this will be the axial plane, all right. So and the hinge line is the line which connects the maximum curvature, right?
Yes, sir.
Okay, so when those things are oblique, right, so this will produce some kind of so for example some kind of intersection, but those will not be the, so usually what happens, usually the intersection between foliation and the hinge line, so hinge line is basically the intersection between the folds forming surface and the axial planes or the foliations. But sometimes it may not happen. Sometimes the foliation might be at some angle with the axial plane, right? So this is the foliation, this is the axial plane. There might be some kind of angle, all right. So what will happen? It will produce these lines. Those are transactions, right? So those are not, you will rarely see those in the fields, but they are there. Okay, so those
Sir,
will, yeah,
say in this slide they are talking about a rotating strain field
yeah.
during folding. Sir, what is a rotating strain field?
Okay, suppose you are deforming something, right? So initially when you deform something, mm, or you deform something, so for example for the fold you deform, so what is happening, the extension will be vertical and the compression will be horizontal, right, if you deform something. So the strain ellipsoid will be vertical like this, like an egg, right? So if the strain field rotates, right, if the strain field within, so there is a rotational component, so for example within the deformation process, if there is a rotational component, so strain field will rotate, right, and with that it may uh, see the foliation and fold axis, they may develop obliquely to the bulk flattening direction. But the bulk flattening direction is basically which will develop this foliations, right, and the folds may get rotated, right.
Yes, sir.
Okay. Do you have any doubt? I can again explain.
Sir, I don't understand how rotating strain field act on some object or any structure.
Okay. Suppose you have a, so what is the strain field here? Or so it is like that, okay? So anything in this domain, it will get stretched. Anything in this domain, it will be compressed, right? So it will produce some kind of folding, right? So this layer is foldable. I mean, it can buckle at that particular P and T. Now you have a strain field that is, so suppose there is a rotational component also, right? There is a rotational component, right? So after some point of time, what will happen? It will be like that, right? All right, but the bulk compression direction will be same, right? Suppose you have a compression in this direction and have a shearing force like this, right? So it will rotate the strain ellipsoid, right? So when it will rotate the strain ellipsoid, so it's rotating the strain ellipsoid, right? So this will be rotated, the fold will be rotated like this, right? But the general compression direction will be horizontal. So this is the general compression direction, right? It is same, it is not changing. Due to this rotational field, due to this rotational field, this strain ellipse is rotating. So now, so as the bulk compression direction is same, the foliation will always occur perpendicular this to this, right? So this is the foliation. The
So this means rotating strain field cannot rotate cleavage planes.
so there is this, it can rotate cleavage planes also. So the thing is,
Yes sir, समझ गए. But maybe lesser with lesser speed.
yeah, yeah, because it will be always, uh, say for example, it will be always perpendicular to the bulk compression direction, right?
Yes sir, and also it depends on surrounding rock.
Yeah, yeah. So I think that will be all for the foliation. So I'll move on to the lineation part. Yeah, so linear fabrics are more or less like the planar fabrics, but the only difference is that linear fabrics are mostly defined by mostly occur due to the intersection of two planar fabric, or it might be defined by minerals. Like there are some minerals which have and asymmetrically long or excessively long c-axis, right? So for example, biotites, so those anisotropic minerals. So those minerals are very prone to produce the mineral lineations, right? So those are the fabric that we also have to study, just because in the foliation, suppose for the study, what do we need for any kind of deformational study? We need to identify the x jet plane, right? So now you have a general compression direction here and general compression direction here. So foliations will develop horizontally here, right? So this is the foliation planes. So what are those planes? If we want to draw it three dimensionally, so it will be something like that. Okay, it will be something like that. So those planar fabrics will develop inside the rock. So what are these planes? These planes are xy planes, right? So this is the compression direction. So this will be z, right? And in this plane, you will have x and y both, right? It can be oriented in this way. It can be oriented in this way. So you don't know. It can be xy. This can be xy, right? So for the deformational study, we need the xz plane, right? So if the x is oriented in this direction, so your xz plane will be this one. If the x is oriented in this direction, so your xz plane will be this one, right? So you can never know for sure. But the mineral lineation is the only thing that will guide you to identify the x direction. Why is that? Because mineral lineation or the lineation, mostly mineral lineation that happen uh, towards the x, the following the x direction. Are we clear?
Sir, sir,
Yeah,
I have a doubt in this.
yeah, yeah.
सर एक्स डायरेक्शन सर, ये जो भी डायरेक्शन है सर, ये तो हम अपने से सर डिसाइड करते हैं ना कि सर किधर एक्स रहेगा किधर वाई रहेगा. तो हम लोग कैसे भी ओरिएंट जिस हिसाब से अपने रॉक को ओरिएंट करेंगे उस हिसाब से हमारा लिनेशन हो जाएगा. तो सर ये बोलना कि लिनेशन हमेशा एक्स में रहता है, ये सर मुझे कुछ समझ नहीं आ रहा है.
So I, if I understand your question correctly, say for example, this is a rock, and okay, so suppose this is a rock, and let me see the camera. Yeah, suppose this is a rock, and you are rotating the rock, right? The hand specimen. So the x is now in this direction. That is what you are you asking? Hello, Suraj? Suraj, are you there? Am I audible? Tushar?
Hello.
Yeah.
Yes, sir. I
So
can't see camera because I am unable to pin the face in. Yes, sir.
can you see it
Now.
now?
Yes, sir.
So you are asking like, suppose this is oriented in this way in the hand specimen, and this is rotate the sample, so it is in a new direction. That is what are you asking?
यस सर, क्योंकि सर ये जो कोऑर्डिनेट्स है वो तो सर हमने ही सेट किया है, तो फिर ये सर कैसे मतलब।
Now, this is the hand specimen, right? You are talking about,
यस सर।
but we have to measure them in the field.
यस सर।
So in the field, so all the rocks will be giving the x direction at a particular, the particular direction. So, so the x direction of everything at a particular region will be more or less same.
सर एक चीज़ मुझे इसमें पूछना है कि जिस डायरेक्शन में एलोंगेटेड ग्रेन्स ओरिएंटेड हैं उसको ही हम एक्स बोल देते हैं,
Huh.
या जो एक्स होता है उसमें वो ओरिएंटेड होते हैं।
It's, like you said, like if the mineral is oriented in this direction, so if
वी
you
कॉल
can
इट
add,
एक्स।
yes, so that is the x direction.
और हाँ, या फिर अच्छा, यस सर, ठीक है,
So
समझ
that
गया।
is the x direction. It's not like you, it doesn't make any sense, right?
यस सर, ओके।
Yes, I have to share my screen again, I think. Yeah. All right. Yeah. Yeah, so these are some examples of primary lineations. So any kind of linear feature that you see in the field that is not the result of a deformation, you can call them primary lineation. But in structural geology, we are more concerned about the forces, the strain direction, those things, and those are associated with the deformation. So we are interested in the lineations that are produced by deformation. Okay. Yeah, the lineations are also penetrative as foliations. So um, yeah, so they may be visible for something, a particular surface. What is meant by that is, suppose you have a rock or a block like this, and in that block you have, inside that you have minerals oriented like this, right? So this will be visible in, suppose this is the xy plane, right? If this is the xy plane, so z will be like this, right? So what will you see in this plane? You will see some kind of circles, right? Right, you will see some kind of circles. So this is x, this is z. So okay, no, I am wrong. Oh yeah, so this is xy, yes. So this is x and this is z, yes. So this will be xz plane. So in the xz plane also you will see these things, right? But in the yz plane, which is this one, you won't be able to see the uh, foliations, lineations. All right, is that visually perceptible?
सर एक असाइनमेंट है सर, उस इसी तरह से रिलेटेड है सर, वो मेरा गलत हो गया तो सर उसको एक्सप्लेन कर सकते हैं।
ये रिलेटेड है?
यस सर, इसी से रिलेटेड असाइनमेंट क्वेश्चन नंबर 9, आई थिंक 8 या 9।
कौन सा वीक का असाइनमेंट है?
सर ये कौन सा वीक है, 7th शायद।
7th वीक?
ये सर फोलिएशन वाला जो है वही।
क्वेश्चन नंबर 8?
8 और 9, यस सर, 8 9 आपको
9, this one?
देखना पड़ेगा।
This one?
यस सर, नीचे नीचे वाला था, 9 था शायद थी।
This one, 9?
नो सर, इसके भी नीचे था।
This one?
ये वाला, यस सर, ये वाला, यस सर,
10?
9 ही है शायद, यस सर, 9 9 9 सर।
9? Okay.
एक्स वाई प्लेन एंड वाई जेड प्लेन सर, इसमें ऑप्शन में है।
Okay.
यस सर, 9।
So, in an outcrop, a well-developed foliation is present which contains an ellipsoidal voids and spherulites as linear markers. Choose the correct statement. The ellipsoidal voids and spherulites represent stretching reliation. Yes. The ellipsoidal voids and spherulites represent the lineation direction in the xy plane. Yes. Represent lineation. Yes. So, what is wrong? I mean, all of this A, B, C are correct.
यस सर, अब समझ आ गया। उस टाइम पे सर ये गलत हो गया था मेरा।
Okay. Yeah. Okay. Okay. So lineation, like in the stereonet class, we have already covered like how to plot the linear elements in a stereonet. So I'm not going to repeat these. If you have question, then only. So this is what I was talking about, right? So in the XY plane, you will see these circles, this and maybe the small
यस
things.
सर, सर दिस स्कीम इज कंफ्यूजिंग, लाइक ऑब्जेक्ट ऑब्जेक्ट लिनिएशन सर लिखा हुआ है, बट वो किसके लिए लिखा हुआ है ये समझ, मतलब व्हिच वन इज रिप्रेजेंटिंग व्हिच वन, कांट अंडरस्टैंड इन दिस स्कीम।
Okay. These two are called object lineation. Okay, and this is called platelet lineation. I am not familiar with these terms, so these are not really. So if you go through a book, maybe it is probably taken from this guy's book. We'll see his name again later on. Yeah, JP Boor. Okay, so job or whatever, okay, whatever be the pronunciation. So maybe in his lecture notes, if you search this name JP Boor, so there are online available lecture notes, right? So yeah, so online available lecture notes. So you can go through that. There he has, I think, properly mentioned like what is what, but these are not really very so for example very distinguished feature, right? These are something that you can know, but it's very specific. Okay, so intersection.
इस वाले में सर थोड़ा सा इसमें कंफ्यूजन है
Yeah.
सर। सर एक इंटरसेक्शन लिनिएशन सर इसमें दे रखा है
Hmm.
सर, इसमें फोलिएशन भी है, हमारे पास सेडेंटरी फोलिएशन भी है प्रेजेंट।
Hmm.
तो सर हमको ये कंफ्यूजन है कि इसमें हम किसको सेडेंटरी फोलिएशन बोलेंगे और किसको लिनिएशन।
Sedimentary foliation is the primary foliation, right? So primary foliation means bedding plane. So you can see the bed, you can see the bedding plane, so it is oblique, right? And there are
यस सर,
these uh, vertical faces. This face, vertical face, is basically the cystosity. It's not written explicitly, but as this is written intersection lineation, so these are secondary foliations, these vertical
सर
front
दोनों
facing
तो सर
faces.
सर दोनों तो वर्टिकल प्लेन और ये सेडिमेंट्री प्लेन का इंटरसेक्शन ही है।
No, see, the thing is, it is this diagram, the front facing part of the diagram, it is not, so that's what I am saying, it is not explicitly written here, okay? But the front facing diagram is basically what usually people try to show. Like, this is the convention. What is in the front part, that people write here, right? That is the convention. The crenulation lineation is this one, not this one.
सर इसमें सर मैं पर्टिकुलरली सिर्फ इस डायग्राम की बात नहीं कर रहा हूँ सर। इस तरह का कहीं भी सर रॉक अगर हमको दिखता है या सैंपल है तो
So you
सर।
have to consider the intersection between the secondary foliation or any say for example, if you have a foliation like this, all right, and you have another set of foliation like this, so there will be intersection, right? There will be
यस सर,
intersection, right?
यस सर।
So here there will be one intersection, here there will be another intersection, so those are called intersection lineations, right? So these foliation, they may be primary, may be secondary, it doesn't matter. So it can be one, the intersection can be of a primary and a secondary, or it can happen with the secondary and a secondary. All right, doesn't really matter, but the intersection means like two planes are intersecting, and at the junction of those two planes, the feature that is produced, that is called intersection lineation.
तो सर इस तरह से सेडिमेंट्री रॉक में इंटरसेक्शन लिनिएशन होने के लिए एटलीस्ट टू ओरिएंटेड वेडिंग प्लेन्स होने चाहिए।
नहीं, I didn't write primary plus primary, right? The bedding planes the bedding planes are formed at a static condition. So in sedimentary case, so it will be like horizontal mostly. So it's not like that you have a bedding plane horizontal and then you have a bedding plane vertical. It's not like that. So you have a primary foliation and then you have a secondary foliation, which will only happen if deformation sets in, right?
सर सेडिमेंट्री रॉक में सर जब भी हम देखेंगे तो सर बेडिंग तो हमको सर सरफेस पे ही दिखेगा। सरफेस पे एज वो हमको
Not
लिनिएशन।
necessarily, not necessarily. So bedding plane, suppose you have a sedimentary rock, sedimentary layer. So now after the layer is formed, maybe the whole region got tilted, right? So in the surface you will see the bedding plane traces, right? You have a bedding that is formed like this, and after some time it got tilted like that. Okay, can you see the camera?
यस सर।
Yeah, so it got tilted. So in the surface, in the outcrop, you will see the stresses of that bedding plane. You won't see the bedding plane.
यस सर, बट जो ट्रेसेस होंगे वो सर लाइंस ही तो होंगे ना, तो लिनिएशन हम उसको बोलेंगे ना शायद।
No, see, the outcrop is basically an erosional surface, right? I am talking about foliation, not the outcrop. So the outcrop that you are walking on, it's the erosional surface. It's not any kind of foliation. So foliation is definitely the surfaces that form due to deformation. Say for
यस सर।
example, you are on the field, right, and there is some little hillock in the field, right? Maybe due to some reason, right? There will be something they piled up something or something. Imagine that thing actually happens if your ground is slowly moving. Say for example, Himalayan forelands, or what is called. In so whenever Himalaya is just meeting the plain, just before that, there is some kind of slow activity. So some kind of slump, or what is called, very little motion is there, so it will just pile up like this, right? So those features, those are, and then again, like if any river or any wind just cut out some part of it, and what we are left out with, we're left with is some kind of erosional surface. Whatever we see on the surface, all of them are mostly erosional surface. It's very difficult to get a fresh surface, right? But yeah, there will be weak planes, like the cystosity are the weak planes. So if the erosional processes, the weathering processes work, and they tend to break the rocks from those weak planes. But usually we see the erosional surfaces. But here the intersection is of the foliation and the two foliation planes. So you have to be very observant at the field, and you have to point out like this is the surface that we want to look at, right? You cannot like anywhere if you see a lineation, so you if you want to take data of that lineation, that will be erroneous, right? So you have to first, so foliations are easily traceable, so first you trace the foliations and then you try to figure out, okay, so this is the xy plane. So you see from the all possible angles, so this is the xy plane, and then you see from different, if you are convinced that the 3D orientation of the axial of the foliation plane, and then you on that foliation plane you want to find out the x direction, and then from that you find out, okay, so this is the xz plane, and then on that plane you start observing things to get the maximum deformation signatures, right?
Yes, sir.
Okay. Okay, yeah. Hmm. Okay, so there are different these silicon lines are non-penetrative. So what is happening? They are basically surface features, right? So one portion of rock is moving over the other, so it produces some kind of instability between that contact. So the surface gets scratched or waved, right? So those produces this kind of lineation. So those are not penetrative lineations. So if you made a thin section in here, so you won't see those lineations that is present in that thin section. It is only present on the surface. Yeah, so these are different kinds of lineage. This is how you show like what was the movement of the rocks. Oh no, this is, sorry, I'm sorry. So this is intersection lineation. Yes. So this is the bedding plane. This gray thing is the bedding plane, and these stacks, these are the foliations, right? So the foli the so these, so on the foliation plane you are seeing the beds. So those are intersection lineations, right? Yeah. Why it got selected? Oh, okay. Yeah, so there are different intersection lineations. Like here, this is a fold. So this is one the form surface of the fold, and the form surface we are seeing these vertical planes, which are lineations, which are foliations. So the intersection of this form surface and these S1 planes are intersection lineations. Yeah, so this is more like dicing. When you dice the vegetable, if you dice then into direction, what will you end up with is a rod-like structure, the pencil structure we call. So in the raw in the field also, the outcrop scale also, you can get this kind of features. Aren't they interesting? Yeah, so granulation of little folds, so small scale holes, and more interestingly, this is one electron image. So that is observed on a. It's not photographed by using optical rays. It is photographed using electron rays. And you see, this distance is 5 micrometers. It's very small. So on that small scale, also you can actually see. the cannulation cleavages, right? Yeah, so these are Malian special kind of you know special kind of what should I say, structure that you can find if you have a particular competency contrast. So not always everything will get folded, right? So for a particular competency contrast, you can have this mullions, right? So this competent layer will form this very sharp furrow or very sharp valley, and then you have a very gentle, very smooth top, right? So these, for example, this is the scale of say
Hello.
20 centimeter, right? So this entire thing can happen at this 20 centimeter, right? So this is a
सर
mesoscale
इसमें
feature.
यस सर सर इसमें सर बताया कि जो सर हेलो
Yeah,
इसमें सर इसमें बोल रहे हैं कि ये कॉम्पिटेंट और इनकम्पिटेंट लेयर जो है उनके बीच में सेपरेशन क्रिएट होता है तो सर यहाँ पे कॉम्पिटेंट लेयर तो सर समझ में आ रहा है इसमें इनकम्पिटेंट लेयर कहाँ पे है
incompetent layer, they didn't draw the incompetent layer, it's just on the top of it and the bottom of it. Okay.
सर डिडंट गेट दैट
Okay, we draw this. This is the whole diagram, I mean the whole picture. And you have the competent layer here in between. And this is the incompetent layer. So when you apply force at some point of time, so usually what we have seen that these layers get folded, right? So this does not happen in this case. What does happen? It produces a structure like this. Okay, whatever you are seeing on the picture, that's the half of it,
सर
right?
दिस इज लाइक बुदिनाज
No. So in Budinaj happens at say for example an extension environment, right? You have a compression from above and you have well, any direction. Suppose this is Budinaj. Uh, so this is the extension direction. This is the compression direction. But here this is the compression direction and this is the extension direction, or maybe in any way.
यस आई गेट इट
Okay, in any way like that. Okay. Yeah. Okay. No. Yeah. Okay, so yeah, those are stretching lineations as I just previously just showed you in the diagram. So what is the stretching lineation? I think all of these are very descriptive and we can actually figure it out from the class, right? So yeah, I thought I will
सर
cover the folds this week, but I could not. Yeah, tell me.
सर आई एम अनेबल टू अंडरस्टैंड द स्ट्रक्चर्स रॉड्स
Rods.
यस
Okay,
सर
okay. So these parts are called rods. These parts. So it is extended in the third dimension, right? Inside. So it is like a rod, right? This is a rod, this is a rod, and you just fuse them together. You will
सर
end up.
मलियन स्ट्रक्चर्स एंड रॉड्स आर डिफरेंट सर एक ही में होते हैं दोनों
What are you asking? Let me just go through. Oh, I'm really sorry. So this is say for example, rods are different structure, right? So those are cusp and lobes, right? So these are cusps, the sharp portion of cusps, and this. the top part, the higher part are lobes, right? So rods are different thing, entirely different thing. So those are mineral that will deposit in a particular fashion, just like a rod, just like a pencil. Suppose you have in the field, you will see lots of pencils of quartz that are oriented at a particular direction. So those are different. In mullions, you need the competency contrast, right?
Yes, sir. इसका सर इसमें सिंटैक्सियल फ्रिंज एंड एंटी फ्रिंज सर वो भी नहीं सुनाया था।
Where is it?
इसके नीचे सर नीचे और
Where is it?
हाँ यहीं पे सर यही
This one?
प्रेशर शैडो ये सर।
Okay. uh, so the picture is not very clear here. So what can I say is, suppose what is a wall rock? A wall rock is basically, say for example, maybe a host rock, you can say here. So this is the core, maybe this is called the core, and the fibers of the same mineral. So I mean, the same mineral will elongate, right? So this is syntaxial, but here suppose this is garnet, and there's an entirely different mineral will produce here, I mean will be deposited here, right? Do you know what is a pressure shadow? Do you know what is a pressure shadow?
यस सर यहीं पे सर पढ़े हैं बट थोड़ा सा डाउट है इसमें सर। प्रेशर शैडो मतलब सर यही समझ कि प्रेशर वहाँ पे जो है वो रिलेटिवली सराउंडिंग के कंपैरिजन में
Come
लो होता है जिसकी
and
वजह से
that,
वहाँ प्रेसिपिटेशन स्टार्ट हो जाता है।
yes. So okay, sorry. Yes. So for the syntaxial fringe, the composition will be same. For the syntaxial fringe, this composition is same throughout. But for the antiaxial fringe, this is different, which is creating the pressure shadow, and this is different. So for example, here this pressure shadow is produced. So fringe of fibrous quartz around the pyrite, right? So these are all syntaxial. These are all the opposite one, which is antitaxial, right? These are all antitaxial, but I can't find. Uh, okay, so I will. What I will do, I will upload different photographs of antitaxial fringe and syntaxial fringe. Right, everything you are seeing here, these are all, I guess, antitaxial. Okay.
यस सर
So I will
मतलब ये
upload.
सर
I will upload the photographs, the natural photographs. I mean, if I can find on the internet, I will upload them. Okay. So these are just different terms. So more or less, it's that it's all. What is the purpose of finding a pressure shadow is that you can get the x direction from the pressure shadow. All right.
यस सर सर इसके
Otherwise,
नीचे वाले
it's
पीपीटी में भी कुछ स्कीम दिया हुआ है जो वो सर समझ नहीं आ रहा कि क्या सर उसमें बताना चाह रहे हैं। ये सर ये
I don't even understand what is this. Okay. So what I can see is that these are different kinds of pressure shadow fringe. So these are the structures, right? So you see here, you see these structures, you see these things, or here these things. Can you see these lines?
यस सर
Yeah. So these are the schematic diagrams of these. Okay. So what kind of different structures you can have, right?
यस सर उसमें भी सर फेस कंट्रोल्ड एंड डिस्प्लेसमेंट कंट्रोल्ड कुछ इसका मतलब ही नहीं समझ आ रहा है क्या।
I'm not sure like what is the phase control and what is displacement control. I will look into it and I will post it in the announcement section. Is that okay?
यस सर श्योर।
Okay. Okay. So yeah, I will end the class here, class today here, and we'll meet in the next week. All right.
यस सर थैंक यू सर।